So now we're going to take a look at trend number 2 with the size of ions. So not just atoms, but ions, remember, are things that have gained or lost electrons. That's the definition of an ion. So now we're going to look at something that gained an electron or lost an electron. The first one we'll look at is the cation. A cation is something that's positive, and a cation has lost an electron. And here's a nice picture of a cation. It happens to be lithium. So here's lithium's nucleus. Lithium, of course, is right here on the periodic table and has 3 protons in the nucleus. And I made the nucleus way too large compared to how it would be. And then it has the 1s electrons filled, and then the 2s electrons would have 1 electron in it. If it lost this electron, that's why I put an X over the top of it, then it would become an ion. And maybe it becomes obvious what happens to the size of this atom when it loses an electron. Since it doesn't have that electron shell anymore, now the atom got smaller. So it went from having 3 protons attracting 3 electrons to now 3 protons attracting 2 electrons right here. And so therefore the ion is smaller than the regular atom. This is the general trend for cations. Cations get smaller. All right, let's take a look at anions. So anions, remember, are ones that gain electrons. So they get 1 electron in their shell. So here's a picture of the atom of carbon. Carbon on the periodic table has 6 protons in its nucleus, atomic number 6, and so I put 6 positive little charges in the nucleus. That's way too large compared to how I drew this picture. And then we'd have the 1s electrons right here, the 2s electrons right here, and the 2p electrons right here. And actually in carbon it would have 1, 2, 3, 4, 5, 6 electrons to start with, but then it would gain an electron right here. So the gain of electron would cause it to have 1 more electron than the number of protons. If you count them, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then there's 1 more electron out there. Well, what happens if you have 1 more electron than the number of protons? Well, now this electron, or these electrons, obviously experience less pull towards the nucleus, and therefore it gets bigger. And so anions, generally negative ions right here, get bigger when they gain an electron versus their regular atomic size. So in general, cations get smaller and anions get bigger. Cations get smaller and anions get larger. Just got to make sure I've got that written down here right. So on the chart, which I'm going to show you on page 305 in your digital book, you'll be able to see just a list of a bunch of ions right here. And you can see lithium right here lost an electron, now it got smaller. So it went from 1.28 down to 0.9. Okay? And then negative ions. So here is fluorine right here, 0.5, and then the anion is now larger, 1.19. So it increased in size because the anion got larger, it gained an electron to get bigger. And you can see that is just the general trend right here for all cations and anions. So here's a problem. An example problem. Arrange K plus, CO minus, Ca plus 2, and S2 minus in decreasing size. Decreasing size. So from biggest to smallest. Alright? It turns out that if you look at these species on the periodic table, potassium's right here, calcium's right here, chlorine's right here, and sulfur's right here. So they're all pretty close to one another with the number of electrons that they already have. Calcium normally would have 20 protons and 20 electrons, potassium 19 and 19, chlorine 17 and 17, sulfur 16 and 16. So they're nearby one another. So these species, since now potassium lost 1 electron, now looks like argon. Chlorine gained 1 electron, now looks like argon. Calcium lost 2 electrons, now looks like argon. and sulfur now gained 2 electrons, now looks like argon, are all called isoelectronic because they all have 18 electrons when they are in their ion state, because they have the same number of electrons since they lost 1, lost 2, gained 1, gained 2. So the thing that's different about these is their protons. The protons differ in each one of them. They have the same number of electrons, 18, but their protons differ. So potassium has 19 protons, chlorine 17 protons, calcium 20, and sulfur 16. And so the attraction for the 18 electrons is going to be different in each one of these ions. Which one would attract the electrons the best? Well, the one with the most protons. And so we'd think that this one would probably end up being the smallest. And actually, you're correct. That would be the smallest one. And so if I'm listing them from smallest to largest, calcium would be the one that would pull the electrons the closest because it has the most protons in the nucleus. Next would be potassium. And you'd be correct because potassium has 19 protons in it, attracting 18 electrons. How about between these two? Well, chlorine has 1 more proton, so that would be the next largest size, and then the largest sized one, of course, would be the one with the least protons in the nucleus, and that would be the sulfur -2. We'll be back with our next trend called ionization energy on the next video.